relay. We are going to use the 50 Hertz metric and press OK. There is existing. Let's put it as OCR2. Okay. And okay. Wait for it until the one-line view operate. Okay. It's just opening. Okay, here we go. Wait for it. Here we go. We have a small system. Small system consists of grid. This grid supplies several loads through a transformer and transmission lines. A very simple load system. What we are gonna need a power grid right there. We will need bus bars. One in there, and one there, and one there. Okay. This is the first bus bar. This is the second bus bar. Okay. This is the third bus bar. We will have a transformer connecting this power grid to this bus bar. There will be a cable connecting between this bus bar and this bus bar. This is the cable. We will have several loads, lumped load. One right there and 3 down there. Another load. Okay. One right there and one right there. Okay. Escape. Okay. We will need a protection along each port. We can see we will need a protection to protect this bus bar 2. We will need also protection right here to protect this transformer. We will need a protection to protect the cable, protection for this load, protection for this load, and this load, and this load. Okay. Before anything, let's start by adding the rating. Let's add the rating for this system. It's 66 kV with a short circuit of 500, okay, of X over R of 20, okay, and this transformer has a primary side of 66 and a secondary side of 22, and they're of 200 megavolt ampere. And the impedance is going to be according to IEC standards. Okay. That's for the transformer. We will have here a load, and there are several loads. For this load, we will have a power of 20 megavolt ampere, and the total power is constant kVA. And this load is going to be 20 megavolt ampere, and also it's constant kVA. For this load is going to be 50 megavolt ampere, and it's also going to be constant kVA. And for this lumped load, we will have 40 megavolt ampere and also constant kVA. Okay. Now for the four loads, we will need to select this cable. Let's first select any kind of cable, and let's using the load flow decide is this design good or not. The cable distance is going to be 2 kilometers. Okay. We are gonna need a cable rating of 22 kilovolt ampere. So we are gonna choose the 22 and 25. Press OK. We are gonna choose the copper one, okay, as it has a larger capacity. We will choose 3 conductor per core. Also, we are gonna choose the rating of ours is 50 Hertz. Okay. Now we have two types, this type or this type. Let's use this one. Okay. We are gonna choose the 300 for now. Let's choose the 400 for now. Okay. And let's see the load flow analysis. Is that cable correct or not? Load flow. Okay. Here we go. Let's look what overloaded. There's several. First thing, the cable. One is overloaded. How much is overloaded? By 600 times. So we will need 7 cables of these cables to overcome this. So we are gonna need 7 cables. Now, when we use 7 cables, as you can see, the error has been mitigated. Another thing we have error with is there is a voltage drop along the pulse 3 is higher than 5%. So we are gonna overcome it using the tap changer by adding -2 to the primary side to see what will happen. Again, let's see. Here the voltage has been reduced. Let's see. -2. Okay. Let's run it now. +2 will reduce the voltage in secondary, as we discussed in the load flow. Okay. Now the load voltage along this port is equal to this, and the voltage is equal to this. We can use, instead of percentage, the value of voltage, so it be accessible. Instead of showing the kilowatt and kilovar, let's show the kilovolt ampere and the current on alongside. You can see below right here we have a load draw about 543.8 ampere, and here another load draw 1359, and here 1088, and the total of this current is 2991, and for this one is 540. And for the tire bus bar is going to be 3000. And here is going to be a step down in the current, so it's going to be less. It's 1200. And okay. Now we will need a server protection device. As we said, we will need to protect the transformer, so we will add something at this point. And to protect the bus bar too, so we will add another one right here. For this cable, so we will add another overcurrent relay here, and here, and here, and here, and here. Let's understand the protection device first. Let's open the pane to understand the protection device first. How it's being done. As you can see, the protection devices is going to be consist of several bolts. First thing, the measurement in our case here is going to be CT, or current transformer. It's going to reduce the current to a limit. This limit will be entering a overcurrent relay. This overcurrent relay will give a signal to the circuit breaker to trip the system. So we will need to add along the way CT and overcurrent relay before anything. Let's add CTs at every port we need. We will need someone here, and here, and here, and here, and here, and here, and here. Okay. For everyone, we will need overcurrent relay. One right there, and one right there, and one right there, and one right there, and another one right there, and another one right there, and another one right there. Okay. Let's take the rating of the CT. The rating of CT depends on two parts. First part, which is the ratio of CT. We call it X over 5. The ratio used for CT used in production is basically calculated based on X over 5, as X is the value of required ratio could be product. The value of X is going to be the next in line greater than the 3-phase short circuit current times 5 over 100. And the I nominal. So the value of X should be always greater than both these two. Greater than I nominal and greater than the short circuit current times 5 over 100. Okay? Let's see it for each one. Let's do load flow analysis to understand it. For the lumped load 2, the value of load current is about 1088 ampere. So 1088 ampere. Okay, this is the nominal current, I know. The I short circuit current at this port should be calculated by short circuit analysis. So let's do short circuit analysis. Okay. No faulted bus bar. Again, let's fault it. We will need a fault right there, so let's add a bus bar right there. It's actually the same fault at there, so let's fault this port instead of adding bus bar. Fault it. Let's fault this bus bar. Fault current. Okay, let's run the flow, the short circuit analysis. Wait for it. The short circuit current about 58.263 ampere current. 58.263. Okay, this is the value is the short circuit current. We will need to multiply it by 5/100. Okay. And let's go to calculator. $58,263 times 5/100. We will get about 5,000. This value is 5,800. This means it should be greater than this value and 1,000. So this one overcurrent relay, we use the next in line, which is going to be primary side and secondary side ratio of 6,000. 6,000 to 5 ampere. Okay, this is our ratio. The burden of the overcurrent relay should be calculated from the overcurrent relay datasheet. I'm gonna put it for now 10 volt ampere. Let's do the same for this one. The short circuit current at this bus bar is actually 58, the same value. Let's calculate the load current. The current is going to be 500 and here 1,300 ampere. So for the pose 2 is going to be similar to the same CT here. So this CT is going to be similar to the other two, 6,500, 5 ampere, similar 10 volt ampere, and same for there. 6,000, 5 ampere, and okay. Now let's do it for the bus 2 for these 3 CTs. Okay, let's first calculate the short circuit current at this bus bar. First unfold this bus bar, then fold this bus bar. Both bus bars are folded, so let's unfold it. Okay, now let's run the short circuit analysis on this bus bar. Okay, it's about 60,355. 6,355. So for the other three, it's going to be 60,885. As I saying, 355. 355 ampere. That's the I short circuit current on the busbar. Okay, let's now calculate the value. 5 times 5 over 100 times 60,355. Okay, we're gonna get 3,000. So it's going to be 3,000 for the circuit breaker. Again, let's see it for this one. It was 58. Again, 58 to 63 times 5 over 100. We're gonna get 2,900. So the next in line is 3,000. Next in line for the lower one is 3,000, not 6,000. So this circuit breakers is going to be 3,000. This overcurrent relay, this CT is going to be 3,000. Okay, same for this. It's going to be 3,000. Sorry for this. Okay. Again, let's calculate it for this CTs. It's going to be 60,000. Now let's delete 60,350 times 5 over 100. We're gonna get 3,000. The next in line is going to be 3,100. 3,100. If it's available, take it. If it's not available, take the next in line available for you. In my country, the available one is 3,500. So I'm gonna choose the 3,500. Okay. Also, you need to make sure it's higher than 3,500, greater than the nominal current, or it will not be able to handle pulse. As you can see, the nominal current for this circuit breaker is 3,531 ampere. So the next in line for this CT is going to be 3,600. Okay, the next in line greater than this. So for this one, it's going to be 3,500 over 5. Volt ampere burden is going to be 10 for now. Here is the same. 3,500 over 5. Here is 10 ampere. Okay. Again, for this, it's going to be 3,600 over 5. The next one available for you. Okay. It's going to be 10. Okay. Now let's do the same for this one. Here we are gonna calculate the short circuit current at this point. Okay, let's calculate the short circuit current first at this busbar. Let's unfold this busbar. And let's then fold this busbar. Okay, now let's calculate the short circuit analysis. Wait for it. It's about 62 kiloamperes. So let's calculate it. 62,332 times 5 over 100 is going to be 3,100. The next in line, 3,500. So I'm going to choose 3,500. but I should keep in mind the value of the current at this point. Is 1,200. So the next in line is going to be, as we said earlier, as 3,500. Okay. 5 ampere and also 10. That's for the CTs. Okay, guys. After we done the CT selection, see you in the next lecture where we are going to enter the data for overcurrent relays. See you in the next lecture. Bye-bye.